Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to look at this non-standard trigonometric equation. If the sum of these four trigonometric functions is 5, find the values of x in the range of 0 and 2 pi. To start with, we know that tangent x is equal to sine x over cosine x, cotangent x is equal to cosine x over sine x, secant x is 1 over cosine x, and cosecant x is 1 over sine x. To get rid of the fractions, we multiply the whole equation by sine x times cosine x. Therefore, we have sine square x plus cosine square x plus sine x plus cosine x is equal to 5 sine x times cosine x. Do you notice something? Right, the first two terms add up to be 1. Let's call this equation 1. Now, we have a sum of sine x and cosine x on the left-hand side, and their product on the right-hand side. What should we do? If we can express the product in terms of the sum in a different way, it would be so nice. We're going to use a substitution. Let u equals to sine x plus cosine x. Squaring both sides, we'll have sine square x plus 2 sine x cosine x plus cosine square x. Again, it can be simplified to 1 plus 2 times sine x cosine x. That's the product we want. Rearrange the terms, we get sine x times cosine x is equal to u squared minus 1 all over 2. Let's call this equation 2. Now we put everything into equation 1. The unknown is changed from x to u. So the equation becomes 1 plus u is equal to 5 times u squared minus 1 over 2. To simplify that, multiply both sides by 2, and we put all the terms to the left. Then the equation is 5u squared minus 2u minus 7 is equal to 0. It is a simple quadratic equation. Using cross method to factorize it, then we have two answers. U is equal to 7 over 5 or negative 1. Wait, are they reasonable? Let's check if there's anything weird. When u is equal to negative 1, then sine x times cosine x is equal to 0. So either sine x is equal to 0 or cosine x is equal to 0. What's the problem? Well, you can see that in the original equation, sine x and cosine x are the denominators. If either one is 0, then it will be undefined. So this case should be rejected. Therefore, sine x plus cosine x can only be 7 over 5. Now we put this into equation 2 to find the value of the product. So sine x times cosine x is equal to 12 over 25. With the sum and the product, what can you think of? Yes, let's set up a quadratic equation with the roots sine x and cosine x, which is y squared minus 7 over 5y plus 12 over 25 is equal to 0. Multiply the whole equation by 25. Then it is in the standard form. We can use cross method to factorize. So y is equal to 3 over 5 or 4 over 5. We get two sets of possible answers. Sine x is equal to 3 over 5, cosine x is equal to 4 over 5, or vice versa. Because both sine x and cosine x are larger than 0, therefore x is in quadrant 1. For x between 0 and 2 pi, x can be arcsine 3 over 5 or arcsine 4 over 5. Of course, you can also take arccosine. Can you see anything special about these two values? They come from the famous 3, 4, 5 right angle triangle. This is a really nice result, isn't it? If you want to know more interesting problems about trigonometry, please check out the links of the videos and playlists on the screen and in the descriptions below. See you in next video.